We now discuss the solution of a problem from the section Integral Calculus. This question is related to the definite integral, and this question has appeared in the joint entrance examination main held on 28th June 2022 in the second shift. The given question is, let f be a function from the set of real numbers into itself, and f is given to be a differentiable function such that f of pi by 4 is equal to root 2, f at pi by 2 is 0, f prime at pi by 2 is 1, and let g of x is equal to the integral x to pi by 4 of f prime t into secant t plus tan t into secant t into the function f of t bracket close with respect to t, where x belongs to the semi-closed interval pi by 4 to pi by 2 closed at pi by 4 end and open at pi by 2 end. Then the limit extends to pi by 2 minus of g of x is equal to, we are given four options. Option A 2, option B 3, option C 4, option D minus 3. We are given f is a real valued function defined on the set of real numbers, and it is given to be f is a differentiable function such that the value of f at pi by 4 is root 2, the value of f at pi by 2 is 0, and the value of f prime, the first derivative at pi by 2 is 1, and let g of x is defined as integral x to pi by 4 of f prime t secant t plus tan t secant t f of t bracket close dt, where x belongs to the semi-closed interval pi by 4 to pi by 2. Then required to find the limit extends to pi by 2 minus of g of x. That is the left limit of the function g of x at pi by 2. We now discuss the solution of the problem in detail. F is a real valued function defined on R and given to be a differentiable function. The values of f at pi by 4 and pi by 2 respectively are root 2 and 0, and the value of f prime at pi by 2 is given to be 1. And g of x is defined as the integral x to pi by 4 of, the integrand is f prime t secant t plus f of t tan t secant t with respect to t, where x belongs to the semi-closed interval pi by 4 to pi by 2, like this. And we have to take this gx as it is, as it is. That means gx is defined like this only. That's it. Right. Now required to find the limit extends to pi by 2 minus of g of x. That means the left hand limit, LHL, left hand limit of g of x at pi by 2. Agreed. First of all, we have to materialize g of x. We observe that the integrand is this one, f prime t secant t plus f of t into tan t secant t is d by dt, the derivative of f of t secant t. So the derivative of f of t secant t is secant t into derivative of f of t, f prime t, f of t into derivative of secant t is secant t tan t. So apply the product rule, and the integrand is precisely d by dt of f of t secant t. So let's get into g of x. So g of x is equal to integral x to the definite integral x to pi by 4 of the integrand is equal to the integral x to pi by 4 of d of f of t secant t, the perfect differential of f of t secant t. So the integral of the differential is the function. So that will be equal to f t secant t. So and to be evaluated between the limits x to pi by 4, where x belongs to the semi-closed interval pi by 4 to pi by 2. Thus, we have obtained a function of x where x comes from this semi-closed interval. So, evaluate for the upper limit f at pi by 4 into secant of pi by 4 minus for the lower limit f of x into secant x, and f of pi by 4 is given to be root 2. Secant pi by 4 is also root 2. Root 2 into f of x into secant x. And that is 2 minus f of x by cos x. And mind you, cos x, that is secant x, is coming. Cos x is sitting in the denominator. But x is not equal to pi by 2 because x belongs to this semi-closed interval where it is open at pi by 2 end. That means x will not take the value pi by 2. Therefore, no threat will be there for this. So because cos of pi by 2 it will not take. Therefore, it will be non-zero. Agreed. We continue in the next slide. So this is what we have done, and x belongs to that semi-closed interval pi by 4 to pi by 2. Agreed. Now limit extends to pi by 2 minus of g of x. That means the left hand limit of g of x at pi by 2. That is equal to limit, taking the limits on both sides. Limit of 2 is 2 only, minus limit extends to pi by 2 minus of f of x by cos x. Agreed. Now here limit extends to pi by 2 of minus of f of x by cos x. So we take for x pi by 2 minus h. So then we write limit extends to 0 f of pi by 2 minus h by cos of pi by 2 minus h. For the left hand derivative, for the left hand limits, we do like this. So limit h tends to 0. F of pi by 2 minus h is f of pi by 2. Because f is a differentiable function, f is continuous, therefore this will happen. And cos is a continuous function. Cos of pi by 2 minus h, limit h tends to 0 will be cos pi by 2. And f of pi by 2 is given to be 0. And cos of pi by 2 we know it is 0. It takes the 0 by 0 form, which is an indeterminate form. When it is an indeterminate form, what we do is we apply the L'Hopital's rule. So this will be equal to 2 minus limit extends to pi by 2 minus of applying the L'Hopital's rule, the derivative of f of x, f prime x, by the derivative of cos x, that is minus sin x. That is we are applying the L'Hopital's rule. Now again, so 2 and this minus into minus plus into limit h tends to 0 because it is a left hand limit. We write f prime of for x pi by 2 minus h by sine of pi by 2 minus h. Agreed. So take the limit as h tends to 0, 2 plus f prime of pi by 2, because f prime of pi by 2 is given to be 1 by sine of pi by 2 minus h, as h tends to 0, sine pi by 2. So f prime of pi by 2 is 1, sine pi by 2 is 1, so it is 1 by 1. 2 plus 1 by 1, that is 2 plus 1, that is equal to 3. So the limit extends to pi by 2 minus of g of x, that is what we are required to find, and the value of that is 3. So let's look at our options. Our answer 3 appears against option B. Therefore, the answer to this question is option B. And that is the detailed discussion of the solution of the problem, which is based on the concepts of definite integral, and added to that the limit concept is also added to that, and it is definitely a good question, and I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.